Hi friends, there we go. That's better. Um, Welcome to my weekly live stream about the Uno platform. My name is Jérôme Laban. I'm the CTO of the Uno platform project, the Uno platform open source project, and I spend about an hour every week taking a look at Uno platform current development and features. Talking about what's happening and looking at specific issues or new features that we want to implement, and of course discussing with whoever's on the stream at that time. And if you have any other questions later on, if you're watching this stream, the recording of this stream, then drop us a message on Discord or on our GitHub discussions. So there's that. We were having we published yesterday an article about recreating the Goodreads app using Uno Figma. So that was interesting. So if we want to take a look at that, it was an interesting scenario for us to take a look at to make that good article about that particular UI and in Uno Figma. So today we're going to be taking a look at the newest .NET 7 feature, which is the ability to have the ability to call JavaScript code from .NET. I'm going to get there. So previously, and .NET 6 and below, the only way to call JavaScript was through JavaScript evaluations, and that was not particularly fast. And that's why we developed a few things around this to that particular problem for performance to get it to go faster. And that was using the ability to go through generated code using C# and TypeScript. And I'm going to be showing that to you. So what I'm doing is opening the Visual Studio, the Uno solution in Visual Studio, and using the cross-targeting override props as always. So if you're familiar with this stream, you've probably seen that more than once. The idea is that you clone that file and change it to be on the target framework that you want to use. And in that case, we're talking about .NET 7. So it's not in the list here because I didn't copy the file for the last time. But you can see that I want to do some WebAssembly and I want it to be .NET 7. So now I do have it, I'm going to be opening the solution and we're going to go take a look at the code that does the interop for the Uno platform. This is not useful. So let's go to see what we do have in WebAssembly. So most of the code that we have can be done through two pieces. The first one is doing JavaScript invoke. And actually, let's go find pieces that do actually call JavaScript that way. Let's go find, let's say in Uno wasm here, so that one. And we're going to take a look at not IO. Actually, maybe IO is the right one. Dispatcher queue, not dispatcher queue. That one is not particularly interesting. Threading, I think I had storage. Let's go for storage. Okay, so if we go to the WebAssembly application data, you're going to find in some cases that we are doing interoperability using JavaScript invoke. I think I do have that in that file. Let's see if we do have those here. Okay, there you go. So we have here for the application data container interop. So it's in the application data container. We're invoking, we're trying to get values from JavaScript using the TS interop marshaller, and it does call a method that's called invoke.js. So that one is actually a bit more special. So it uses a generation. Let's actually find another one. So that one is actually too specialized. So let's go for devices maybe. Let's go for devices. I think we have, that's light maybe, not that one. Or sensors, we're gonna find sensors. We have one gyrometer for WebAssembly. There we go. Okay, so that's a good one. So this is what we're doing. we're using the WebAssembly runtime invoke.js method, and that method is going to basically invoke JavaScript directly into WebAssembly. From WebAssembly is going to invoke that JavaScript method into the JavaScript runtime. And if we search for that method, so we're talking about Windows device sensor gyrometer. If we go to, and that's where it gets interesting because it's in another project for now. And we're probably going to be able to change that using the newer features. So if we go to the TypeScript folder in the Uno UI project, we're going to find a lot of interesting things here. And most notably, we get devices and sensors, and we have gyrometer here, so a TypeScript file. And what we're doing is invoking, find that one. So we're using the JS type here, which is Windows devices, sensors, gyrometer, initialize. So we're invoking the JavaScript method that's behind that TypeScript file. So we're just jumping to the JavaScript side using JS invoke. So the problem with this is that it actually needs to, it requires the browser to parse that string and then execute that string as if it were JavaScript. And the second problem with this is that it's not particularly performant. And the second part is that in some cases, and particularly in secure context, JavaScript evaluation is just plain disabled. So that means that if we want to be able to go further into the securing of applications in specific contexts, which may happen if the developer wants it, then we have to remove all of this to use non-evaluation invocation. So that's something that we've been doing. So if we go back to application container here, we can see here that we go through an interrupt marshaller, and that interrupt marshaller is doing something that goes with some types of generated code. And that part is a bit faster because it goes through a bit more code. There we go. So in there, we're doing things like this. So we have an application data container, try get param values, and that is is tagged as a TS interrupt message. So that's what we're doing inside of Uno, not what .NET does, but it's going to be, that's where we're going to be taking a look at afterwards. And we're using the JavaScript, the .NET marshalling that is being used for platform invoke, so pinvoke, when you tag something with DLL import. That's the same technique that we're using. So we're giving this to the .NET runtime, which is converting that message into a set of bytes that can be then deserialized on the JavaScript side. So now if we could take a look, if we search for this, so for some reason Visual Studio doesn't want me to search, which is annoying. Probably, there we go. So if we search for this, we're going to find the endpoint for this particular code. So we're basically unmarshalling what's been passed in as a byte array, so pretty much a memory pointer. And we can do this with the other way around, which is a native memory pointer. So we're talking native in the sense of it's a byte array that has to go back and forth. And we take a look at that unmarshal method. It's a bunch of generated code that's derived from the fact that structure has an attribute that's called TS interrupt message, and it generates this saying, well, at the index 0 of the byte array that was provided by .NET, this is a string that needs to be converted to a JavaScript string. And same thing, we have two strings. So if we take a look here, we have two strings. So we have the key and the locality, and we could probably find the same using the other method. So let's see if we have the return. We can go take a look at the return value. So we have the marshal back, And the marshal back pretty much does the same thing. So it takes a string, it allocates, it does malloc. So if you take a look at that code, it looks like C code, to be honest. And that's what is always amazing about this. It's you're doing C code in JavaScript because you're manipulating memory as if you would do it in C or C++. And so we're transforming that string into a string that was mallocated. And then we also set a Boolean as an int32 at position 4 bytes. So that is a pointer to a string, and that is a the location of an integer inside of a byte array that will be sent back to .NET for digitalizing. So that's what we have right now. It's interesting. It works quite well. It's better than using JavaScript evaluation for most of the cases. Hi Magnets, thanks for joining. So this is faster, but it's not as fast as the new thing that's been introduced by .NET, and it's from Pavel Savara, which is from a developer from the WebAssembly team on .NET, and he's been developing things that looks like this pretty much, but on the .NET side. So what you can see here is that I opened the .NET, the Uno solution as a .NET7 solution. And we're going to take a look at one of the implementation of that JavaScript import. So I did a test because I wanted to see how fast everything goes, and we can actually run that test. So let me, while I'm showing you, I'm going to be showing you what the code does, and we're going to be building the application so that we can actually see the results. So what I wanted to try is what's the performance of that JS interrupt marshaller technique that we have, which does JavaScript invocation, but through the .NET marshalling techniques against what the .NET team has developed, which is using this one. So they're pretty much doing the same thing, which is passing a string over to .NET to JavaScript and getting back a result, which it's pretty much the same string. And there are two ways to do that. So if we take a look at the code, take a look at the JavaScript that we have here. The first JavaScript that we have, let me find you that one. So we have the when single string. I think it's somewhere in there. The when single string. So pretty much it takes the string as parameter and returns the same string that was passed in. So that's the first one. So that's the method that's being called using the legacy system that we have in Uno. And the new one is pretty much that method, that function actually. So it's a function, JavaScript function that takes a value as a string as an input and returns a value. So you can see that the JavaScript version, so the TypeScript version of that method is way simpler. So using the new system. So if I make a comparison between the two, the first one was doing some marshalling inside of the method, doing some marshalling at the end. What do we have here? Could not locate. What am I doing? It seems to have an error somewhere. Let's see what we have. Xamarin Mac. No. Looks like I broke something. So let's see. .NET T4 was restored. Looks like I probably have to restart because I updated, I reloaded the solution without everything building properly. So that's probably why. So let's see if we do it again. So Visual Studio probably has cached a few things that we need to discard. Which preview do I have here? I'm not sure it's the right one. Preview 4. Okay, so there's preview 5 out, but that's good enough for what we're doing. So let's go and open it again and see if it goes better. So it's probably because we made some changes recently and the solution that I had opened didn't have all the updates that were needed. So let's see if it helps. So we're having quite a few projects now that we have added .NET 7. We're at, what's the number of projects we have? 158. That's not too bad. Probably going to be adding a bunch of few additionals when we're going to be changing the support for unit tests, because our unit tests are still built on .NET desktop, and we want to change that to be running .NET 7 instead. It's going to be a better experience for everyone. Okay, so let me see if it builds again properly. Hope it will this time. I think we need to change that. So we've been having race conditions in the build for Uno, and it causes that kind of thing. So we've been trying out a few solutions, but that probably isn't the right one because it logs a bit more in Visual Studio, and that's not a very good experience. Okay, so it's still having that issue. It looks like, so it says target definition file is not the right one. So that's one of the few things that we have because of the targets that are loaded by Visual Studio. And sometimes they don't rebuild properly. So let's see if we build that task directly. Does it help? So let's keep that opened and continue seeing if we have something better. Oh, wow. Nope, not that one. So that's one of the things of Visual Studio that I would like to see changed at some point in the future. When you're moving things around, they're not moving at the right place. I just pinned everything, but it got completely somewhere else. It's something that dates back from a large number of versions of Visual Studio, but oh well, doing the same thing. So okay, so what do we have here? Uno tasks. Okay, looks like it compiled better. So yeah, so we have the two functions. They're significantly smaller. And if we take a look at the way that it's implemented in .NET here, the interesting part is that so the legacy one that we use in Uno currently is using strings and invoke.js and things like that, and structures for parameters and others. So that's not particularly good. But the other one is using, I'm sorry, I'm not going to go to the implementation. I'm going to go to the definition. It's using the new JS Import feature. So that one is basically saying that method is a partial that's going to be implemented by something, and in that case, it's going to be a source generator. And we're saying when invoking that method, it's going to go to global this when single string net7. So we're talking about that target here. So I had to register it at the top. It's something that we're probably going to have to change to adjust .NET or see it differently. But let's say for the time being that this is good enough, and we're going to be invoking methods that way for now. So we're invoking methods directly here, and what that does is that it will generate automatically, because of the JS import attribute, it's going to generate automatically a bunch of things in the code behind, in generated code. And let's go take a look at what it is. So that's what it looks like, and it's not particularly pretty, but it's fast. So and we're going to take a look at the results when we open the solution. We open the application when it starts to run. So what it does is store a function bind, which is something that is invoking so it took the string that was as a parameter of the JS import attribute, and then it went to register it inside of the JavaScript on the JavaScript side. And once it has that, then it does a few other things like initializing return values and exceptions, and the actual invocation of the method is here. And the interesting part here is that there's no evaluation done at that point to get to JavaScript. So it's actually all using closures and execution through methods. So there's, because the parameters are known, and you can see here that the generator, so it's actually a bit too large. So let me, I edit this. No, not really. Okay, so let's put it in a notepad for now. So if we take a look at that method here, if we split it in parts, we have the name, we have a null parameter. I'm not sure what that is, but not particularly important. And then we have the set of parameters that are passed, that are provided. So that first one will be the parameter, and the last one will be the return value. But what that does is that on the JavaScript side, a JavaScript method is function is generated, and that means that it's going to be super fast to execute. So if we have, there you go. So it built. So let's run the app. Right, start the build again, but it should be faster. So it's all super fast. Most likely not allocating. You can see there are ref arguments everywhere from the argument buffer here, so that there's no copy in memory. And it supports quite a few types of parameters. Supports, of course, the simple parameters like strings, integers, all the primitive types that we can get for .NET. It supports also arrays, for what I can remember, and that's probably something that we're gonna have to try to see if it actually works. And it also supports passing in lambdas. So, and that's another interesting part. So we can get, so when you want to invoke something that goes to the .NET side, to the JavaScript side, sorry, and then you can pass in a delegate, and that delegate can be invoked back to .NET, and that's pretty powerful when you want to do some callbacks of any kind. So that's going to be very interesting. So the point of all this is trying to show you what we're doing and where we're going, and to see if we can get to use the JS import feature with what we have. And to a certain point, I didn't go into too many details and try to understanding the feature in itself, and we're going to try to do that. So we're going to take, I think we're going to take one of the samples that we had there. I think it was, let me take a look at that one. I think it was the, it was in the storage, application data. I'm going to try to see if the application data container can be changed. To, say, for instance, the set value here, or maybe not that one. It's actually, I cannot take the other ones because I don't have access to gyrometer. But let's go for this one. So it will be trying to transform that set value. So when we're in .NET 7, we're going to be using JS Import to call for those methods and see what we can get. So let's see. The application has started, and so this is our unit test runner inside of Visual Studio. So if we take a look at that specific method here, I'm gonna do one test perf. I run this. So this is using the interpreter. So it's not as fast. Interpreter. It's not as fast as it could be using AOT, but it's good enough for what we're doing. And if we take a look at the performance, we're talking a debug build as well, so it may be even faster when running with the full optimization of the interpreter or everything else running. And we can see that with the .NET 7 interop, we're talking about the same number of calls. We're talking about 7 milliseconds, and we're talking about iterations of 1,000. So it took 7 milliseconds to do 1,000 invocation of string returning string. And it took 18 milliseconds to go to do the same thing, but using our previous and a current existing interop. So that's pretty amazing. And that means that if we change all the interop that we have in Uno to use that newer feature, we're going to get something that is even more performant than what we have currently. So that's going to be interesting. So let's go and see if we can change that particular method and use the newer set of features. So the first part is, do we need to make it compatible with the previous versions of .NET. So Uno supports .NET 6 and 5 for WebAssembly. So that means that we cannot use that feature because it comes from a runtime that does not exist at that point. So, and doesn't have all the newer features that we can get using the JS import attribute, because that attribute does not exist. So what we're going to do is just say we're in .NET when we are using .NET 7 and above. Then we're going to be using that newer feature. So let's see. And if so, what we want to do is invoke that method, pretty much. So not exactly that one, but close to that one. So if we search for application data container, as I said before, we go to, so that window is a bit too small. So if we go to Uno here, we have the TypeScript. We get interop, no, not that interop. So Windows, storage, and then we have application data container. And what we want to be able to invoke is that method. So I think we're invoking application data container. So we can see here that we're invoking a private method. So we're poking through to get to that specific method, and that's not the right way to do it. It's private, but it's something that you cannot call from the outside if you're an application developer that's using Uno. So, but Uno is able to do it for itself. So what we want to do is being able to invoke that method and be able to go faster, pretty much. So set value is having a set of parameters. So we're talking about key values and locality. So let's make a class. Actually, I'm not sure if I can make it inside that one. So I'm going to have to move it away. Actually, let's try. So let's see if it works as nested class. That I don't know. So it has to be a static class. So I'm a bit puzzled by the fact that we don't see net7 or greater here. It should have been there. It looks like Visual Studio is not liking that much. So let's go for .NET 7. We're going to put the operator afterwards. So it will be, let's call it net7 for now. Net7 interop. It's a class. And we're going to do a JS import. We're going to put it as a local import. Okay, so the using is a bit too large. I don't want this because otherwise I would have to put the imports everywhere. Let's go take it from the other part. So we're talking about JS import. It's declared. It's declared here. So okay, so it's this one. Oh, not in that file. And we want to import something that uses global list. So, and that's one of the problems. We're going to have to take a look at how that works, because it may not be doing what we want. So for some reason, it's not importing. JS import. Okay. Public, so we want to return nothing. It's a void. And we want to send pretty much all of this. So I don't, that's one of that's one thing that's interesting. So there's an enum here. So we're going to see if we can get the enum on the other side. That I don't know. So it's going to be application data container. Let's call it that way. Application data container. It's a partial method. And it's supposed to be marked as partial. So it's not happy with what I said. Cannot declare instance member. It has to be static. Static, of course. And is that enough? It has to be a partial type as well. Okay, probably input the right class, the right type. So static partial class. There you go. Must declare a body because it is not marked abstract external partial. Okay, so let's take a look at what I did on the other one. I don't recall. So internal static partial. Oh, it must not be public, I would guess. Is that what it is? Maybe not. Okay, so it says it's contained is not marked partial. So the type is marked partial, but for some reason, that's probably because it's the arrow type. Okay, so that in that case, so it has to be public, but that's not the problem. So an interesting thing is that they created an analyzer that allows you to tell if that JavaScript import is using the right things, the right modifiers. But in that case, it's not the right ones, and it's likely because that class is defined as a nested class, so it's probably not working as a result. So let's put it at the top and see if it behaves better. Okay, so far it works. It says that the type Windows storage data locality is not supported by source generated JavaScript interop. So enums are not supported. So that's the one thing that we wanted to know. Then that means that we're gonna have to put a string. Oh, so it does support to some extent some types, so we can see strings that are supported, of course, but it looks like enums are not there. I think there was a discussion around this. What should the value be when translated to JavaScript? Should it be a string? Should it be the value of the enum when you have it on the .NET side? I don't think it was settled, but anyways, that's what we get. So we have that partial, and we can go to it's already implemented. Take a look at that. The generator is run automatically, and it does all the things that we have. So locality, key value as the parameters, and all of this that is available. So that's pretty nice. Okay, so we have the global this method. That's not the right one. That we're going to change. That we're going to change afterwards. On the .NET7 side, what we should be able to do is to invoke this part and do set value. And then we need to do the same thing pretty much that we had here. So locality to string invariant key and value. So that makes for a smaller invocation in that case. There's a bit less of code here. There's no string, the magic string with specific formatting, so that's pretty nice. So that's one of the interesting part. Now we have to be able to invoke that method properly. So we're talking about a global this, so we have to point to the right location. And one of the things that we can do is trying to understand how that attribute is actually used when taking a look at what the runtime is doing. So if we search for that bind.js function in the .NET runtime, we're going to try to go and find out what that does really underneath. So we have the bind.js function underneath. Let's go see what that method does. It's calling a bind.js function impl, and it's using a bind.js function, which is an interrupt method that goes, probably an internal call that goes directly into JavaScript. So we need to find that one if there is one that exists. Okay, so we can see here that it's an internal call, bind.js function, and it goes to a method that's called monowasm bind.js function. So let's go find what that method does. And the monowasm bind.js function is supposed to be a JavaScript method. So we can see here that it's exported. And we're going to find what that method does here. Okay, so it does quite a few things. So we can see here the function name. We can see the module name. We can see the signature. So that's the parameters that we have on that side. So if we take a look at the code that is generated here, we have so the bind function. So there's I think it's the method. If we take a look at here, so we have the function name here. We have the null parameter that is the monostring ref, which it's the module name, and then a set of parameters saying what are the parameter types that we have. So I didn't know about that one. Just module type discard is probably the void. So we're invoking a void method, so it does nothing. So there we have it. Now what we want to try is to determine how can we find that method. How can we invoke any kind of method? Can we invoke one specific method? Does it have to exist in a specific way? Can I invoke something that is not part of the global list, for instance, or is part of the global list but defined in another way? I think there's a lookup function here. Let's see what that method does. So that lookup function is doing, so it's splitting the name. It's searching for internal. It's searching for this. And otherwise looking at scope. So it's scope, it searches for global this, and then tries to find the methods using dots that lead to the method that needs to be invoked. So what we should be able to do is take the method that we have here in the TypeScript container. So it should be Windows storage, application data container, then try get value. We should be able to invoke that method directly. So let's try to see if it works that way. So we need to have global this because it's a known leading string that searches for methods inside of global this. So that's what we're going to try to do here. So we need uno. So it's global this Windows storage, application data container, and then the method will be try, and not that one actually, it will be another one. So we have application data container. It's going to be build storage key. Interestingly, there's supposed to be 3 parameters, and it looks like we have only 2 here. So it may do weird things. Well, actually, it's not that one. Okay, so we do have a problem. So we cannot call that method because that method is built specifically for being invoked as part of the original TypeScript invocation techniques. So that is not good. So we're going to be making another method that is called tryGetValue. Probably should be changing that one to be let's call it, I don't know how to call it. Native, maybe? Let's call it native. So tryGetValue native. And we are going to be changing this code to make it actual, to make it as an actual method that's called tryGetValue and not the native one. So private static tryGetValue. And in this time we have a set of parameters that are the actual ones that we have on the WebAssembly side, which is locality, key, and value. So we're going to take the exact same names. And because it's TypeScript, we have to swap the parameter names with the types. And there we go. So we need to pull out that part. We need to pull out that part. And the thing is that, so that one's actually interesting because we do, is it try get value? Oh, actually, I think I'm wrong. It was not try get value that we wanted to do. But I think it was set value. So let's not do that one. Mixed it up. Okay, so the one we're doing is set value. So that's why the parameters were not the right ones. Okay, so web parameters, locality, set items. Okay, so that we're going to extract the parameters for that one. So it's set value. So that one we're going to call it native because it uses native stuff. And so we had the parameters that we wanted that are, so application data container, set value. So not that one. Which actually does not return anything. We don't need to return anything. And we needed, so for some reason it's not picking it up, but that's fine. So we said 3 ones, locality, key, and value. So we can remove all of those because there were actually, those should be up here. Grabs the value. And yeah, that's correct. Const param is still defined above. It's supposed to be defined above. So in that one, this is the native version where we want to be supporting .NET 6 and below. So it needs to be there. And the set value that we're defining here, that one is supposed to be called in .NET 7 because it's directly invoked. So there's no need for having the params available at that location. So we have the parameters here, we have the key, and we have the value. There we go. Okay. So that's pretty much it. So we split the method in two. One is going to be called by the legacy code, slower code that uses .NET 5 and 6. And that one will be called directly by the JavaScript interrupt that we have defined above. So the method that we're going to be calling is supposed to be set value here. And we're going to go into the .NET, into JavaScript to see if the resolution works properly, if it doesn't work properly. So let's go and build all this and see if it works. So I think we do have unit tests that are validating this and runtime tests actually. So if we go for the runtime tests, if we search for application data container. So if we search for runtime tests somewhere in here, we have tests. And if we search for storage, application data container here, we can see. So we have a set of clean, initialize, nothing, set string. And you can see here that we're taking local settings and setting the value through the dictionary syntax and setting the 42 value. So what we're going to do is pretty much drill into what this does and see if we're going through our going to the method that we just defined. So I see there are quite a few people on the streams. Is it something that that you know about and you've seen already? Do you know about JavaScript interrupt if you're doing WebAssembly? That context, is it something completely new? The JS interrupt stuff is pretty new, so Is it something that's of interest to you? Something that you may be using in your apps, by the way. It's not something that's specific to Uno. So if you're doing interop with any kind of JavaScript stuff, that's something that's going to be available to you if you're doing .NET 7. And that's the nice part. So what do we have here? So code DOM is not defined in the namespace windows.system. Okay, so that one is interesting. Okay, so it looks like something got generated. And because we have a windows.system namespace, that's going to be failing. That's going to be an interesting one. Because it's inside of the same namespace and it's something that is available. And the generator is not having the right globals. Or maybe it's something that has been fixed already. So we can probably go take a look at what the JS import generator is doing. And I think we don't have access to that one because it's not part of the generated files. So we're going to be making those appear. To make those files appear, we're going to be taking the attribute that I never remember. And it's the one that I put in the unit tests here. So we can take that block and put it into our Uno WASM here. And just remove the top one because it's not useful. Okay, so if we rebuild, we're gonna get some interesting things here. And if it still doesn't work, we're gonna be hacking our way through. Not a big deal. I'm gonna be reporting the issue, but that's the interesting thing with code generation, is that it's something that you can pick up and do the same without having the generator do it for you. So we're gonna hack it through. So we can see here that in the WebAssembly folder, the UPS folder, we have a new G folder here. Is it the G? No, substitution, not that one. So I'm not seeing it. Did I forget something? Or am I building for something else? Oh, that's correct. I didn't modify the right one. So we need to modify the Uno, not the Uno UI one. Okay, so let's rebuild again. Okay, so we have that problem again, which is good. So if we go to the ops folder, we should be seeing a new folder, which is supposed to be called generator or generated. There we go. And we have the library import generator, which is not the one that we're looking for. And we have the JS import. Is it the one that fails? JS import.g.cs. There we go. So the reason it fails is that the system here is not prefixed with global. And interestingly, this is done properly here for everything but that one. So all of the attributes are all globalized or fully qualified with global in front, but not that one. So let's go and try to find that JS import generator and see if it actually was fixed, because sometimes it may have already been fixed. So let's find, it's called JS import generator, is it? Generator, JS import generator, there we go. JS import generator. It's defined here. No, that's the unit tests. Oh no, there it is. Oh, I missed it. So that's the generator CS project. So the generator itself, it should be around here. Okay, so probably missing a few things, but let's see. We have method declaration, keyboard. Okay, so maybe it's a bit too specific here, so I don't know if it got fixed. Let's see. We're looking for generated code attribute. Can we find it here? Maybe not. JS import code generator. No, not that one. No. Okay, so maybe it's something that is generated in general. We have a syntax provider. We have a generator here. Set of syntax. Stub. Function stub here, not useful. Okay, I don't know where that is, but we can probably open a function. JS generator, JS export generator. Okay, that's probably somewhere in there, but the idea is that that piece here is not defined properly. So what we're going to do is take that code and put it right back into our app. And into our app, it was in the file. It's probably not visible here. Application data context here. So what we need to do is pretty much see that the generated code that we put here at in that file, we're going to just do this. So we're going to say that attribute is not used, so the generator won't run, but we're still going to get the generated code that the generator did for us, which is good enough. And that is not right. Non-nullable fill container. Okay, so that's nullability that's enabled for Uno, but not for that piece of code. So let's disable the nullability feature here, so that we can remove as well, because it's not useful in the same way that we had in the generator. So is it working now? Okay, so let's build and see if it works better. It looks better, that's for sure. Okay, nullability should be used only when generation. Okay, I said restore, but restore is probably not doing what I think it does. So I'm going to be doing enable for now. So is it better this time? Okay, there we go. Now we have it. So we have copied the generated code because of the bug that's here, and I hope we're not too late in the cycle to get that fixed. Otherwise, we're gonna have to get creative. Probably just copy the generator on our end and do the same thing, because it's something that's gonna be specific to Uno, but that's gonna be a problem. Or we could move that class to somewhere else actually, because we're in the Windows storage. So maybe, because in the Windows namespace there's a system namespace. Let's try this first actually. So let's comment that class out, and we're going to move this out. Let's put it at the end, outside of the namespace, and we're going to put it in a namespace called let's call it interrupt for now. Let's call it that way. Okay, so if we do this JS interrupt, and if we put back the JS import here, can we get it to work? So this is supposed to fail unless we do JS interrupt, which is going to be fine. So maybe the generation is gonna work better. Okay, so it must have partial modifiers. Probably missed that part. So it says, oh yeah, I duplicated I didn't move this around. Okay, so there we go. Is it better this time? Let's hope so. Ah, that works better. Okay, so we don't have to copy and paste the code. So this is still generating, but because the method is declared outside of the JS interop in the namespace that doesn't have system, because Windows system exists, we won't have that problem. Okay, so now we can build the app and see if we have something interesting. So let's see. So we're going to be able to go and dig into the JavaScript and put breakpoints to get to the point where we can resolve, we can see if the resolution of the method that we generated is actually done properly, because it's supposed to be, if we took a look at the code properly, we're expecting that this is going to be resolved properly, assuming that Windows storage application data container is actually a public member that's available from global this. It's supposed to be, because that's the way TypeScript works when you're creating a class that way. When you have a class that's defined at the top namespace in the class, it creates a global object that's called Windows, then a nested one that's called storage, and then class, then method or function in that case. And then we can get to something interesting and faster interop at that case. So that should be good enough. So we're getting there. Runtime tests are working. So interestingly, there's another. So you could see it in the generation. So there's a JS import generator. There's export generator. So the export is doing pretty much the same thing, but the other way around. So it says, I have a JavaScript, I have a C# method, and I want to be able to call it from JavaScript. And you're saying, I'm exporting that method, and then it's going to do the right thing at the right time, saying that the method is going to be available from JavaScript. And you're going to be able to call it without doing all sorts of fancy things like the bind static method thingy that we had in previously that was not particularly good, particularly easy to use. So actually, let me go and find that one. It's actually an interesting piece of the execution here. So if I take a look at in the TypeScript, a device that provides something. So let's say accelerometer, because it provides value. So we can see here that JavaScript is getting a method that comes from the .NET runtime that's inside of the Uno assembly here. That is named, the class is named that way, and then the method's named that way. So what it does is generate a callable function in JavaScript. It's untyped, and then you can invoke what you well, in this case it's typed because we're typing it the way we want, but we're typing it that way. But otherwise it returns an any, so you invoke that assuming that the parameters are going to match, and that's what we're getting here. So that's pretty interesting to do. But it does all sorts of evaluation and things that are unsafe underneath, and not necessarily fast either. So JS export is here to do and avoid that kind of things and make it easier for us to invoke. So if we go back to our app, we have it here. Okay, so it started again. So if I search again for the test that I had before, I want to see when set string. Does it work? Okay, so it looks like I broke something. It definitely broke something. So it looks like we have an exception somewhere. that broke the runtime completely, but otherwise it would not otherwise do this. Could not resolve. It says there's no file name, sample favorites. That's not good. And then it fails for additional things. So, okay, so maybe, let me retry this. Looks like I broke a few things while doing my test. Let's see if I restart completely. It behaves better. So sample app's getting there. We're gonna get good at that. Okay, so if we can replace everything instead of Uno to use the newer import exports, we're gonna get cleaner code. We're also gonna get faster code, and we're not gonna have to do anything about the marshalling because we're gonna let everything do. The whole thing is gonna be done by the .NET runtime, and that is going to make the migration path to later versions of .NET way easier than what we're doing currently, because that method has actually been deprecated. So you can't call it you can't call it easily. It really looks like something broke. Yeah, it's definitely broken. I don't know what I did, but it looks like I messed something up. What did I do? That's some interesting part. As it says, there's no file named. Let me see, maybe there's some storage here in application that got. No, there's definitely something that's happening here, because it's not supposed to be doing this that way. Yeah, definitely broken. So let's go and try to figure what happened. So everything loads. Favorites, not a problem. Element ID not found. So there's nothing that that is out of the ordinary here. Maybe in the verbose mode. Okay. I definitely did something that broke the app. So maybe let's try to remove everything and just try again, because we changed a few things recently with the way JavaScript is generated, and it may be related to this, where some JavaScript file was supposed to be generated and are not generated, or maybe generated halfway, and it could be causing that kind of issues, or it could be with the latest .NET 7 updates that we did. And we have some JavaScript that is generated here in a subfolder. There's a JavaScript folder, the JavaScript file. So maybe that file is not integrated properly. That could be. Though I would find it odd, because the whole file seems to be there. So maybe there's something missing. So everything looks to be in order. We're going to try to see if rebuilding everything helps. It's not supposed to happen, so if it happens again, we're going to try to troubleshoot specifically what's missing in the build when we're trying to get to a second build, where definitely there's something that got either not included properly or not in the right version. That can happen. So we can see that JavaScript here is regenerated. It should be, at least. Actually, it was removed. So that's the good part. And then it should be regenerated once everything is done. There you go. So JavaScript, we even have a definition file that shows all the internals of Uno. It's not supposed to be used in any way when you're developing the app, but that is supposed to be there anyways, because that's what the TypeScript generator, that's TypeScript compiler builds. We're almost there. So we have a lot of functions that need to be migrated over. So if we take a look in the TypeScript folder, all of this needs to be migrated to the newer TypeScript generated version of the interop, or to avoid using JavaScript evaluations, because it's a problem and it's a performance issue. So we have a lot of work to do, and that's going to be interesting. Probably going to be needing some analyzer of some kind, so we can detect every use of JavaScript evaluation. So we just stop using them altogether. But if you're using that, know that we're not going to be removing that for the next year at least, because there's quite a bit of code that still uses that, but it may be removed afterwards. Let's say for .NET 9 maybe. So up to .NET 8, likely we're going to keep it there, and then 9 we're going to be removing it. Yeah, for some reason it's still doing the same thing. So I definitely broke something, and yeah, definitely broken. Okay, so and it looks like it got really far. But it could be because we're actually already invoking the methods. Now I know. Okay, so let's go try to figure this one out very quickly, because I have 2 more minutes to spend with you guys again to see what we have, and that's probably why it got broken, because in the startup of the application we were using the application container stuff, so it may be why it fails, and it's probably doing it silently, which is a problem. So let's see. Do we have try get value native here? Try value get native. So we have set value native here, and we have our set value here, which should be called. So is it called? If we refresh, it is called. But is it called because it's using the new stuff or the old stuff? And it looks like it's using the new stuff. So what we do know now, oh, look at that. This is all the conversion stuff that was done automatically by the .NET runtime. Oh, that is super cool. Okay, so that's going to be a nice end of stream. So we do know that it works properly, but we don't know why it crashes afterwards. So there's probably something that is not working properly when we return from the application container to when we're invoking that method somehow, maybe at that location. So maybe there's something wrong that happens here when we're invoking set value. Maybe we're not getting out of that set value or something. But that's going to be for another stream. And that was interesting. So now we do know, and that's one of the things that I wanted to figure out for that stream, is that are we able to have a JavaScript import attribute that uses a complex, or a nested class name to get to a method? And that is available, which is in itself very good, because we're going to be able to migrate most of the code using this. So that's it for today. Thank you for joining and listening. And if you're watching this through the recording, thank you. And until next week, happy coding. Bye for now.